Sairam, having seen various aspects about the mole concept, the interrelativeness between the number of moles, atoms, finding the molecular formula and empirical formula, we will now get into a concept which probably you have not heard till date, but yes, you have studied a lot of things in relation to that, and that concept is given as stoichiometry. So, what is this stoichiometry? Definitely not the English word which is present as such. So, this is a section which deals with the study of relationship between reactants and products in a chemical reaction to understand how much reactants are required and what is the proportion of products that have been formed. So, what is this basically stoichiometry? Stoichi basically means element metry, metron, metry is all measurement. So, this is nothing but measurement of elements in a particular reaction setup. Now, you had actually done the percentage composition and all in the previous class. Now, here what you are going to do is specially going to understand the measurement of compounds in these cases. So, let us consider one example as such where iron metal is reacting with oxygen gas, the bracket in bracket G indicates gas, and then a solid is formed which is iron oxide. Now, what do you understand by this reaction at the outset is that we have studied already about mole. Now, what is a mole? It is nothing but the stable amount of particular element which contains 6.022 into 10 raised to 23 particles. Now, what does this 4 indicate here? It indicates that 4 moles of iron is reacting with 3 moles of oxygen to give 2 moles of iron oxide. Now, whenever you write a reaction, balancing this reaction is very important. You can see that in total there are 4 ions here, in total there are 4 ions here, 2 Fe2, oxygen if you see 3 into 2 is 6, whereas even here also it is 2 into 3 which is equivalent to 6. So, whenever there is equality on the left hand side and right hand side, we see that the reaction is balanced. But the overall composition can be understood as 4 moles of iron react with 3 moles of oxygen to give 2 moles of iron oxide. This is somewhat similar to what you do for a preparation of a particular dish in a kitchen. So, suppose if you need salt, if you need pepper, if you also probably need a little bit of spicy items, cardamom and all, you do not add everything in the same quantity. You do not add 10 gram, 10 gram, 10 gram, 10 gram, everything 10 gram. No, your dish will be thoroughly spoiled. You need to have proper proportions when you are adding various items for your dish preparation. But at the same time, you must have seen that suppose for 10 people you need around say for a particular dish. If you are preparing for 5 members, you might have needed around 15 gram of salt. The same dish if you prepare for 10 members, you will just double the quantities. More or less all the quantities will be doubled. So, the same concept is here that whenever reactants and products take part, they will take part in a perfect ratio always. If 4 moles of iron is reacting with 3 moles of oxygen to give 2 moles of iron oxide, this is the simplest representation that can be shown. If I take 8 moles of iron, then what will happen? The amount of oxygen required also will be doubled, which will be 6 moles of oxygen to give 4 moles of Fe2O3. So, what I am basically trying to tell you is that the proportion of reaction, which is nothing but if I can write it as 4:3:2. 4:3 is the reactant proportion, 2:2 is the product proportion. Irrespective of how you do the reaction, the amount you take, this is the ratio that is going to follow. So, now understanding this parts here, we can also talk in terms of atoms and molecules. Now, this is an atom. We know that an elemental form we can call it as atom, whereas a stable state we can call it as molecule. So, we can also tell that 4 moles of or say 4 atoms of iron will react with 3 molecules of oxygen to finally give Fe2O3, and this is called as formula unit because we have already seen this. What is the formula unit? It is a stable compound which is formed by ionic species. We had seen the example of Na plus Cl minus to give NaCl. Here this is Fe2 plus and O2 minus. So, this is how various types of compounds can be combined with each other. Moving further now, when we talk about stoichiometry, that is nothing but measurement of elements, we have various aspects that can be measured in this. The first one we have already seen, 4 atoms of iron, 3 molecules of oxygen to give 2 formula units of Fe2O3. First aspect we have seen. Now, what is the other aspect here? This also we have seen, 4 moles of iron reacts with 3 moles of oxygen to give 2 moles of iron oxide. Now, one thing is absolutely clear with us that 1 mole is equal to 6.022 into 10 raised to 23 particles. It can be atoms, it can be molecules, it can be formula units, it can be anything. So, suppose I have taken 4 moles, it means that 4 into Na. Now, what is Na? Na is Avogadro number representation, and what is Avogadro number? It is this number. So, if 4 Fe is present, it means that 4 into 6.022 into 10 raised to particles, here it is atoms of iron is present, 3 into 6.022 into 10 raised to 23 molecules, or the other way around you can also call it as particles, whereas here it will be 2 into 6.022 into 10 raised to 23. All this discussion forms on the basis of the fact that 1 mole is equal to 6.022 into 10 raised to 23. So, this is one case study of these relationships which actually has the heading as mole relationship, meaning with respect to mole how are the number of particles associated. Now, let us see about the mass relationship. We have already seen this definition that 1 mole is equal to, this was just now seen, 6.022 into 10 raised to 23. I can call it as atoms or molecules depending on which type of species are present. In general, if I want to call it, I will call it as particles. Now, this 1 mole is also equal to the molar mass of the compound. If atom is present, it is equal to atomic mass. If molecule is present, it is equal to the molecular mass. If formula unit is present, it is present according to the corresponding formula mass. But all this you can generalize, like the way you generalize this as particles, generalize this as molar mass. Now, what do you mean by that? By this reaction, we have already studied till now that 4 moles of iron requires 3 moles of oxygen to give 2 moles of Fe2O3. Now, when I go in terms of mass, I know that the mass of iron is 55.8. Now, this is something that you can get it from periodic table or from exam point of view in the log table that you get it. But how many moles of iron are there? 1 mole of iron is 55.8, that is fine. In total, there are 4. Similarly, in case of oxygen. Now, oxygen you can see that 3 into, this is a molecule of oxygen O2, so therefore it will be 3 into 32, whereas this will be 2 into, so Fe2O3, the calculation aspect is just been shown here for you, because in total you have 2 iron particles which are there, 3 oxygen particles which are there, 16. So, therefore, it is in total it is 159.6. So, when I overall calculate this part, it will be 2 into 159.6 in this case. So, what we understand here is that in terms of grams also, it will be dependent on one another as such. So, this is the amount of overall grams that we consider. Now, see the total mass of iron that is present here, this is per atomic part is 55. So, if you go by into 4 to this case, 8, 4 is nothing but 32, 4, 5 is 20 and 23, and then another 4, 5, 20. So, you get it around 223.2. This is the in terms of gram. This is again say 32 into 3, you can get it around 96 gram, whereas this one it will be 2 into 6 will be 12, 18, 19, 2, 5 is 10 and 11, 2, 1, 2 is 3. So, what you understand here is that to get 319.2 gram of this compound, you need so much of these corresponding particles also. So, one was the mole concept which was interrelated. This is the mass relationship which says that equivalent amount of mass will be required in these cases. So, this was about the mass relationship in terms of stoichiometry, and just to continue the parts here, whatever I explained, the same thing is been shown here, how in terms of moles 4, 3 and 2, the corresponding masses are also generated: 223.2, 96 gram of oxygen, 319.2 gram of Fe2O3. So, if these grams of reactants are present, the corresponding product will be formed. So, this was about the mass relationship that we have seen here. Similarly, volume relationship. Now, what happens here is that volume is a factor which is associated with respect to, generally in these cases, gaseous types of compounds which have been present here. So, it so happens that in these parts, the 4 iron atoms which are there is in atomic form. Oxygen, even if you can compress it into solids or so, its general formulation is given as gas, general formulation. So, therefore, this is one part which can be taken up in the form of STP. And what is STP? We know very well that it is a standard temperature and pressure at 0 degree centigrade, which is nothing but 273 Kelvin, and 1 bar pressure in this case. And that 1 mole is the equivalent to 22.7. Now, since 3 moles of oxygen are present, it will be equal to 22.7 into 3. Now, this mole volume relationship cannot be applied on the solid particles that we tend to get on either sides of the reaction. So, this is all that we have with respect to stoichiometry, and in the further part, we will be seeing applications of this and various problems. Thank you. Sai Ram.